Humanity is increasingly looking beyond our solar system. This began at the 21st century's start. We are trying to imagine interstellar travel. We already know how to launch devices outward. We send probes to outer planets. Voyager probes went into interstellar space. We create orbital stations for people to live in. People can live there for months at a time. But all of this is just the first steps. It has almost nothing to do with real interstellar flight. A real trip to Alpha Centauri will take time. It will take time comparable to eras in history. Reaching even 1% of light speed is very slow. This journey will still take about 400 years. This scenario is the base of the Chrysalis concept. Chrysalis is a 58-kilometer ship. It could house thousands for centuries. Alpha Centauri is a triple star system. It consists of Alpha Centauri A and B. It also has the red dwarf Proxima Centauri. Proxima is the closest star to us. In 2016, astronomers found a planet orbiting Proxima. The European Southern Observatory reported this planet, Proxima b. It is in the habitable zone. This zone has distances from its star. Surface temperatures could allow liquid water there. This does not mean the planet is suitable for life, but this is where the first space ark could go. Proxima b is 4.24 light-years away. That is about 40 trillion kilometers. Even with great acceleration, the journey will take centuries. The team from Earth will never see the destination. This flight is a task for dozens of generations. The Chrysalis concept involves a floating world. A team of Italian engineers proposed this. It was part of the Project Hyperion competition. The idea is simple in its form. Its scale is grandiose. They want to create an artificial world in space. Everything in it is designed for self-sustainment. This includes food and the social system. The ship will be 58 kilometers long. It will be several kilometers in diameter. It will have shells around a central core. This resembles a Russian doll. Each layer will perform its own function. The innermost level is a closed ecosystem. It will house tropical and boreal forests. There will be hydroponic and aeroponic farms. Also, there will be freshwater reservoirs. It will have pastures and aquaculture tanks. This green core provides food. It also provides psychological support. People will live and die under an artificial sky. They will be far from any other nature. The second shell is for public spaces. It includes parks, schools, and libraries. There will be sports complexes, theaters, and concert halls. Project architects understand culture is key. Without a developed cultural environment, missions decline. This is true for multi-generational missions. Human settlements show this on Earth. Polar stations and remote islands show it. A lack of diversity causes psychological issues. Social degradation is a result. In flight, mistakes can be fatal. Such crises cannot happen there. Next are the residential sections. They are for a population of about 1,500 people. The ship can hold up to 2,400. This avoids overcrowding and overloading the ecosystem. The apartments will have artificial gravity. The entire ship's rotation creates it. This is critically important. Experiments on the ISS confirm this. 6 months in zero gravity causes problems. Astronauts lose bone mass and muscle strength. Their cardiovascular system rebuilds. This causes orthostatic intolerance when returning to Earth. They cannot stand without dizziness. During a 400-year flight, such changes are fatal. The living areas are followed by production facilities. These include waste processing plants. There are workshops for making necessary parts. Pharmaceutical labs will also be present. Equipment will repair and upgrade the ship. There will be industrial 3D printers. They can make large metal structures. Robotic lines will operate without human help. The outermost shell stores resources. It stores metals, composites, and fuel. This fuel is for landing modules. It also holds spare reactors. It has everything needed for a long flight. This zone will be fully automated. Drones and repair robots will work there. They will deal with radiation and temperature changes. The ship's center will house the command block. It will have shuttles for landing. Antennas and laser transmitters will be present. These will contact Earth. This will occur in the first decades after launch. At maximum distance, a signal takes over 4 years. A simple, "Hello, how are you?" is not relevant then. Information exchange is still possible early on. Artificial intelligence will work with the human crew. It will analyze data and plan production. AI will maintain the ecosystem and predict breakdowns. It will offer solutions before they become critical. A huge challenge is social stability. People born on board will see the ship as their world. Their culture, language, and habits will differ from Earth. This can happen in a couple of generations. The project provides a continuous education system. This avoids losing knowledge of the mission. Children will study Earth's history from an early age. They will also study astronomy and the mission goals. This is not a whim. Ethnographer research shows complex technologies can be lost. This happens in isolated communities. It occurs if they are not needed every day. Here, their use will be required. Before launch, the first crew will adapt. They will spend 70-80 years in isolation. The Chrysalis team said it will be like Antarctica. Antarctica has a harsh climate. The horizon is closed. Logistics are very limited there. This makes the conditions close to space. Experiments have simulated long-term isolation. These experiments occurred at Antarctic stations. The Concordia project is an example. Data from Concordia shows time perception changes. Emotional reactions become more acute. The ability to work in a team decreases. All this must be considered in preparation. Otherwise, the team will fail. They will return with excuses. Translating Chrysalis into numbers clarifies the task. Proxima b is about 40 trillion kilometers away. At 1% of light speed, the flight takes 4 centuries. The ship is 58 kilometers long. It is about 3 kilometers in diameter. It will weigh hundreds of thousands of tons. Fuel is the main thing. Accelerating and slowing down needs fuel. It requires more fuel than the ship weighs. It is like launching an asteroid into space. At this scale, the challenge becomes clear. The main challenge is delivering fuel to space. The project has a long way to go. After launching from near-Earth orbit, the ship gains speed. Tugs and gravity maneuvers help it. Jupiter and Saturn provide these maneuvers. Then thermonuclear engines will activate. They operate with low thrust. But they are continuous. They accelerate the giant structure. It gets to 0.01 of light speed. This mode needs colossal fuel reserves. Flawless reactor operation is needed. Thermonuclear fusion is unattainable now. This is true for commercial energy. But ITER, NIF, and Spark are helping. If we achieve stable fusion energy, a chance exists. We can build installations to operate for centuries. Braking at Alpha Centauri takes decades. Speed cannot drop abruptly at that scale. A parachute will not work. The same installation will accelerate and decelerate. More exotic options exist too. Giant magnetic sails could deploy. They would interact with Proxima's solar wind. This creates a braking force. These technologies exist in calculations. Engineers are modeling their operation. All this raises ethical dilemmas. What if a new engine is created in year 150? What if it can fly to Proxima in 50 years? Will new ships launch? Will they overtake the generation ship? How will people feel who grew up on the ship? They may learn their path could have been shorter. These questions have no answers yet. But they are inevitable. Perhaps discussing them creates a new space philosophy. Project Doll won the Project Hyperion competition. It won the first prize of $50. This is not enough to build the ship from Lego bricks, but the idea deserves attention. It combines astronomy, biology, and engineering. Sociology and psychology are included. It looks like a beautiful fantasy now, but so do designs for submarines and airplanes. The same is true for space stations. This was a century before they appeared. Perhaps the real ship to Alpha Centauri will differ. It may be smaller or larger, it may be faster or slower, different technologies might be used. But the fundamental questions remain. How do we live and develop in a closed space? This will be for hundreds of years. How do we transmit culture and knowledge? How do we preserve humanity? The horizon is limited by metal walls. You will never see your home planet. Maybe in 500 years, someone on Proxima b will read. They might find the colony archive. They will read about a 2020's group of engineers. These engineers drew up plans for a 58-kilometer starship. They will understand it was this dream in drawings and words. This became the beginning of the story. It made the stars part of the human home.